Previously worked as Ambuja Cement as a trade technical officer, where she focused on providing technical support, conducting site visit, and ensuring customer satisfaction. With total 7 years of experience in the cement industry, she brings a strong combination of technical knowledge and sales expertise. Over to you, Tejal Patil. Thank you.
Good afternoon, everyone. So today I'll be talking about use of slag-based products for strong, resilient, and green concrete. This is an important step towards making construction more sustainable while maintaining durability and performance. So before diving into GGBS, let's take a quick look at GGBS. It's a diversified company with business in steel, energy, paints, infrastructure, cement, and sports. So JSW Cement has plant location overseas and India. So firstly, we have a clinker unit in Fujairah, and we have a grinding unit at Dolvi, Vijayanagar, Salem, that is in Tamil Nadu. In Mumbai and Pune region, we are providing the cement from Dolvi grinding unit. So JSW Cement is mainly into the green products. So that comes under, first is PSC, that is Portland slag cement. Second is GGBS, that is ground granulated slag. And third is ultrafine GGBS. Other than that, we are into the OPC, that is ordinary Portland cement, in some construction chemicals and ready-mix concrete. So now let's talk about GGBS. GGBS is a ground granulated blast furnace slag. It's a byproduct of steel industry. When steel is melted, the impurities in the steel settles down. That is, then quenching process is done, where the molten slag is, the cold water is sprayed on that, and hence the granules are formed which are grinded into the GGBS. This powder, GGBS, widely used in the concrete either as a partial replacement in the OPC or grinded with the Portland slag cement. So here's the advantage of GGBS. So GGBS is not just a waste product, it's a high performance material. It can replace 50% of the cement in the 50% of the cement in the normal concrete, but we can go up to the 70% in mass concrete such as dams or the metro tunnels. So here's OPC and GGBS hydration mechanism is given. So when OPC and water, it forms a calcium hydroxide. When GGBS is added into that, CSS gel is formed and it is a binding product. So when the CSS gel is formed, the concrete is more stronger and offers the low permeability in the concrete. So here the advantages of concrete made with GGBS has been given. The green product, GGBS is the green product, that is the carbon dioxide emission is less in GGBS when the concrete is made with the GGBS. Second is high resistance to chloride and sulfate. Third is reduction in heat of hydration. GGBS mixed concrete gives us improved longer strength that gives a more durability to the concrete. It has a consistent quality product and improved water permeability and hence high resistance to the corrosion. So in case of fly ash, we can use up to 20 to 35%, right? So in case of GGBS, we can go up to the 50 to 70%. And GGBS is the manufactured product, and it gives consistent quality and performance. So here are some case studies we have given. So first is the underground metro rail project. The contractor was Dogus Soma in Mumbai Metro. The GGBS used for its durability and high performance. So in this, 46% of GGBS has been used, which has given, for the M40 of concrete, which has given the RCPT value of 730 coulombs. You can have a look up to it. The second case study is the cable stayed bridge that is built on Zuari River in the Goa. So this is used for the high strength. In this project, the GGBS replacement is 50% for the M55 grade of concrete, and the RCPT value is 158 coulombs. So GGBS isn't just a theoretical, it's already being used in the major products. So beyond large project, GGBS is also used in residential and commercial building across cities like Pune, Mumbai, and some major cities. Here are the list of major infrastructure authorities where we are approved. There is MHADA, SIDCO, NHAI, MMRDA. The next is government infrastructure project where we are approved. Where comes Tata project, Shapurji Palonji, HCC, JMC, BG Shirke. Here are some residential and commercial developer using GGBS in Pune as well as Mumbai. So we have Godrej, Shapurji Palonji as well. It's also gaining traction with ready-mix concrete companies and cement product manufacturers. So here is the list of commercial RMCs, cement product industries, where ACC, Ultratech, Godrej, RDC Concrete are using our product. So to conclude, GGBS transforms an industrial byproduct into a sustainable building material. It makes concrete stronger, more durable and greener while also reducing the cost. With India's rapid urbanization, adapting slag-based product is not just an option, it's a need for building a resilient and sustainable future. Thank you.
Thank you, Tejal, for the great information on behalf of JSW. I would like to invite Jacinta Sequeira to felicitate Ms. Tejal on behalf of Epicons, ICA and VJTI. And there is one more sponsor for today's event, that is NCCL Hyderabad, and they are our platinum sponsors, and with their sponsorship we could have great lunch today. So I think we should thank them also. So let's proceed to our next speaker, Engineer Suhas Zadav, a DGM design. He has 20 years of experience and currently working in Epicons Consultant Private Limited as a DGM in design. The major projects he handled are industrial projects, residential and commercial projects, airports like new international airport projects in Vijayawada and Noida, retail chains projects like D-Mart and Reliance Retail, institutional and hospitality projects, infrastructural transportation project, MMRDA, road and flyover bridges projects in Mumbai. I think he has covered almost everything. Other projects like retrofitting airports, ITS and Indian Air Force Museum in New Delhi. I invite Engineer Suhas Zadav to please take over from here. Thank you.
Good afternoon, or shall I say good evening. I would like to first thank our very own Epicons Friends of Concrete, the VJTI, and Indian Concrete Institute for uh, giving me this opportunity to present or deliver a presentation here. Thank you. And namaskar to all. I am going to specifically speak about the role of structural engineers in climate change mitigation. I know since morning we have been talking about this, and a similar topic has been was there in the morning session. So I prefer to make it very simple so that everybody understands it. I am not going into big numbers or figures. We have now understood already that the major portion of cement and steel consumption is found in the construction industry. And we as structural engineers are responsible for the design and hence also responsible for the figures, consumption figures of concrete and steel. I believe it's time we must start working on the mixed design of concrete with alternative low carbon materials, of course without compromising the strength of concrete, and also what we have been always doing, practice value engineering to put in some more smartness to it so that we can mitigate the climate changes. Let's understand what concrete is basically. Everybody knows it, but concrete is nothing but a mixture of cement, sand, aggregate, and water, along with admixtures. These admixtures could be chemical or mineral. Here we are going to focus on the mineral admixtures. It has been given to me to understand that concrete is the second largest consumed product by human beings in the world after water. So let us go one by one. Let's talk about cement first. Cement is an expensive component of concrete and is found to be responsible for emission of greenhouse gases, indirectly contributing to the climate change phenomenon. Cement manufacturing produces approximately 1 ton of carbon dioxide per 1 ton of cement. So something definitely has to be done about it. Only way is to replace or minimize the cement content by blending it with some green materials. I would like to mention that even IS 456-2000 recommends the use of blended cement in clause number 5.2. So what are these green materials? What can replace or minimize the cement? These are supplementary cementitious materials, as they call it, SCMs, or mineral aggregates such as fly ash, GGBS, silica fume, and few other like rice husk ash and geopolymers, etc. These replacements help in reducing the greenhouse gases and resource depletion also, contributing to more sustainable and cost-effective concrete production. This is a more statistical data available, of course, after proven and experimental verifications. Here you can see the minerals that are possible to be used as replacement of cement content with the extent up to which the replacement is possible. You can see fly ash can go up to 30%, and similarly GGBS, as the lady prior explained, can go up to 70% also. Generally, the benefits of using the SCMs, replacing cement reduces CO2 directly, and the SCMs are often available at lower cost, thus making the concrete more cost effective. You might have noticed that many replacements are industrial byproducts which otherwise would have been a waste, and we are trying to utilize this waste for our advantage. And the studies have shown that concrete with SCMs can exhibit improved durability, strength gain, and overall better performance. The next component and the major quantity in concrete is aggregates. Recently, recycled aggregates, typically recycled concrete aggregates, are proposed to be an alternative to reduce the carbon emissions that is produced during production of natural aggregates. Where can these be used? The recycled aggregates can be used as a substitute in new concrete, mortar, and as unbound materials for pavement construction and landfill. They can replace the coarse as well as fine aggregates, enhancing sustainability. While RCA generally requires careful mix design like any other, it offers significant environmental benefits and can achieve satisfactory performances in pavement construction. Similarly, the benefits of recycled aggregates are listed down here. It conserves natural resources like sand and stone, lowers carbon footprint and greenhouse gas emissions, reduces material costs, and cuts down on the transportation expenses for both waste as well as virgin materials. The other important element in RCC is steel, and steel generates maximum CO2. As a thumb rule, we may say that 1 ton of steel manufacturing generates about 3 tons of carbon dioxide, which is quite huge. One of the ways to control this will be to reduce the steel consumption with optimized and efficient structural design. And this also happens to be the demand of industry, and naturally, most of the fellow designers are willingly and already doing it. And the second best way is to promote recycled steel. That is re-rolled steel. Re-rolled steel is a product that has undergone a secondary rolling process to refine its dimensions and properties. And commonly, re-rolled products can be used as reinforcement bars in concrete, or angles and channels for structural applications in buildings, plates, sheets, and wire rods, with again industrial applications. Now, it has been observed that generally structural engineer would not encourage this with a fear of having substandard quality. I mean, less faith in re-rolled steel. However, in view of climate change mitigation, we should review or revise our policy. We should increase the number of tests instead on the re-rolled steel so that the quality is ensured. Always check the mill certificates or test reports for yield strength, tensile strength, elongation, and chemical analysis. Compare them with the permissible values given in the codes. In certain cases, it may require non-destructive testing or ultrasonic inspection where internal defects are concerned. As regards to cost and sustainability, it reduces the energy consumption of making steel from the iron ore, of course. Further, as the name suggests, it reuses the waste material. Moreover, it is available for lower cost, so quite attractive for budget-sensitive projects, and it also helps in reducing the embodied carbon. Having talked about the mixed design, the next is practicing value engineering. See, for decades, structural design has been governed by codes and standards, guided by two key aspects of strength and serviceability. These codes have served their purpose well, but sustainability must now hold equal weight. The designers must shift their approach to material consumption and sustainability. Sustainability must now be embedded in every design decision, standing on equal footing with strength, serviceability, and safety. I would like to take you all to some basics, fundamentals. These are some load diagrams, force transmission load diagrams. You can see the figure 1 shows the structure is undergoing tension or compression. Similarly, the second figure is the one where tension and compression both are involved. It's nothing but truss form. And then we have the structures transmitting loads by bending action. You may note that the typical bending structure, even though is not as efficient as a tension compression structure, remains one of our most widely used forms because of its simplicity and adaptability. Here, an increased appreciation to form will come with better understanding of the structural behavior. I would like to urge or appeal to structural design engineers and tell them to ask 3 key questions to themselves before at the time of deciding on the structural system. Number 1, how does the structure transmit its loads to its supporting foundation? I am hinting towards the load path here. Second, what type of deformations and stresses are produced by the force transmission? And third, how could the form be improved for material efficiency without compromising its function and aesthetic appeal? This is where the skill of structural engineer comes in. Just for illustration purpose, you can see on screen, there is a figure shows a floor layout of a multi-story high-rise residential building. You may note that there are hardly any columns, and even the beam framings are quite minimal. The concept here is to span the slabs across the walls and do not rely much on the beam framing. You all might agree that when forces flow naturally, the materials perform at their peak, not only from strength point of view, but also from quantity. This principle, though simple, demands a fundamental shift in how we conceptualize the structural framing. Traditional frame structure with core walls localize the load paths onto the columns through beam frames, increasing the overall material demand in the structure. However, for carbon savings, one should identify certain dead walls or partition walls in the building and try to convert them in full or part into structural walls as per the design requirement, and minimize the frame action to reduce the degree of bending within the structural system as a whole. As mentioned earlier, to ensure the load paths take the load directly to the foundation as soon as possible. This attempt is for same. The conclusion is the material efficiency begins with better design and not just better materials. Integrating this awareness into early design process allows buildings to minimize the embodied carbon even before selecting low carbon materials. I believe by working on the mixed design and at the same time working on your value engineering, the today's design engineers are already taken a step forward, and with the right policies, industry engagement and market demand, this approach can become the new standard for construction in India and beyond. That brings us to the end of my presentation today. Dhanyavad. Thank you. Any questions? No questions? Thanks.
Thank you, Suhas sir. Now I would like to request Jacinta to felicitate Suhas Jadhav sir. Sir, please. So next presentation is on ISO, and it will be presented by our MD, Mr. Jayant Kulkarni. So.
आपलं सगळं टाईम टेबल खूप हेवाय गेल्यामुळे खरं माझं लेक्चर मी कॅन्सल केलं होतं, पण वडाळकर सरांनी सांगितलं की तुम्ही एक 5 मिनटं का होईना बोला, कारण सगळ्यांपेक्षा वेगळा विषय आहे. की ISO इंटरनॅशनल स्टँडर्ड ऑर्गनायझेशनचा अप्रोच काय आहे. तर 5 दिवसापूर्वीच पेपर आहेत. एक सोलापूर आणि मराठवाड्यामध्ये अस्मानी संकट येऊन सगळीकडे पाणी भरलेलं आहे. दुसऱ्या साईडला ट्रम्प म्हणतं की हे ट्रुथ का हॉक्स, इट इज ऑल फॉल्स, असं 2 वेगळ्या न्यूजपेपरमधल्या बातम्या आहेत. त्याच्यामुळे यातलं काय खरं असा प्रश्न पडतो. मला मात्र निश्चित असं वाटतं की एव्हरी एफर्ट टुवर्ड्स क्लायमेट चेंज मिटिगेशन इज गोइंग टू हेल्प अस इंडिव्हिज्युअली ॲज अ नेशन. हा सब्जेक्ट कसा काय सिलेक्ट केला, तर ISO 9001:2015 we are a certified company, and they introduced one amendment in February 2024 that climate change mitigation should be a subject that every certified company should put some effort, some look into that. It is not only environmental issue, but it's a strategic business domain, and everybody must promote the awareness and education. So this effort is promoting awareness and education. For internal awareness, we have conducted lectures in our office, and for public or society at large, we are conducting this workshop. What is ISO? Instead of going to detail, the popularly known ISO standards are 9001 for quality, 14001 for environment, 27001 for security, and 45001 for safety. आणि वाय ISO आम्ही स्वतःसुद्धा का सर्टिफाय करून घेतलं, तर इट बिल्ड ट्रस्ट, इम्प्रूव्ज क्वालिटी, सेव्ज मनी, ओपन्स न्यू मार्केट्स, बूस्ट रेप्युटेशन, हेल्प्स टू फॉलो रूल, एनकरेजेस टीम वर्क अँड सपोर्ट ग्रोथ. आता विथ दॅट काय काय अमेंडमेंट आहेत, त्याच्यात टोटली 3 क्लॉजेसमध्ये अमेंडमेंट आहेत. क्लॉज 4.1 आणि 4.2. 4.1 असं म्हणतं की एव्हरी ऑर्गनायझेशन मस्ट असेस इंटरनल अँड एक्सटर्नल कॉन्टेक्स्ट. म्हणजे आपला संपूर्ण कंपनीचा जो व्यवहार आहे त्याला इंटरनल कॉन्टेक्स्ट काय आणि एक्सटर्नल कॉन्टेक्स्ट काय आहे. आणि 4.2 सेज दॅट वी मस्ट आयडेंटिफाय स्टेक होल्डर, म्हणजे आपल्या कंपनीचा कोणाकोणात सहभाग आहे. त्याच्यामध्ये इंटरनलमध्ये आपले स्वतःचे एम्प्लॉई आहेत आणि एक्सटर्नलमध्ये 3-4 गोष्टी आहेत. पब्लिक सोसायटी ॲट लार्ज आहे, त्याच्यानंतर आपले क्लायंट्स आहेत. आणि या प्रत्येक ठिकाणी आपण 6.1 सेज, या प्रत्येक ठिकाणी तुम्ही रिस्क आणि अपॉर्च्युनिटी काय आहेत. बिकॉज ऑफ क्लायमेट चेंज, व्हॉट रिस्क यू आर गोइंग टू फेस ॲडिशनली, अँड बिकॉज ऑफ दिस क्लायमेट चेंज मिटिगेशन, व्हॉट आर द न्यू अपॉर्च्युनिटीज दॅट यू मस्ट फाइंड आउट. त्याच्यापुढे 9.1 हा 3रा क्लॉज आहे, एम्फसायझेस ऑन ट्रॅकिंग द क्लायमेट रिलेटेड परफॉर्मन्स. नुसतं आपण कधी ठरवायचं आणि सोडून द्यायचं असं नाही. At a regular interval, say 1 month, we must track what exactly we are doing. तर 4.1 मध्ये आता मी परत रिपीट करत नाही, पण इंटरनल एक्सटर्नल तुम्ही पार्टीज एकदा आयडेंटिफाय केल्या की क्लायमेट चेंज इव्हॅल्युएशन आपण त्यांचं करायचं. आणि इंटरनल फॅक्टर्स म्हणजे काय काय, एनर्जी यूज, एमिशन्स, सप्लाय चेन व्हलनरेबिलिटी अँड इन्फ्रास्ट्रक्चर रेझिलियन्स. आणि एक्सटर्नल फॅक्टर म्हणजे काय काय, तर आपल्याला हा ॲडिशनल विषय आहे की देर कॅन बी डिफरंट रेग्युलेशन which also controls our business. 4.2 म्हणजे आता त्या लोकांसाठी काय काय करू शकतो. तर आयडेंटिफाय स्टेक होल्डर्स, मगाशी पण म्हटलं कस्टमर, रेग्युलेटर्स, इन्व्हेस्टर्स, अंडरस्टँड देअर एक्सपेक्टेशन. 3 इज ॲड्रेस देअर एक्सपेक्टेशन थ्रू टिपिकल मॅनेजमेंट सिस्टीम. Government regulators, compliance with the climate change, we have to adopt the codes and behave accordingly. Climate and investor demand for sustainability, low carbon infrastructure, local community, safety and resilience, suppliers and contractor alignment with eco-friendly sourcing, and employees. A simple example आहे की आमचं ऑफिस आता when we shifted to a new place which was far away. So every 2-3 persons coming by a shared rickshaw, better to utilize or mobilize one bus so that same number of people can be transported to office with a low carbon emission. आता पुढचे रिस्क काय आणि अपॉर्च्युनिटीज काय आयडेंटिफाय करायला लागतात. फ्लडिंग, हीट वेव्ह, रेग्युलेटरी चेंजेस अँड सप्लाय चेन डिस्रप्शन आर रिस्क. आणि क्लायमेट चेंज रिलेटेड अपॉर्च्युनिटीज काय आहेत, तर ग्रीन बिल्डिंग सर्टिफिकेशन, इनोव्हेटिव्ह मटेरियल्स, एनर्जी एफिशियंट डिझाईन अँड गव्हर्नमेंट ग्रँट्स फॉर ब्रेक इन सस्टेनेबल प्रॅक्टिसेस. त्याच्यानंतर सगळ्यात महत्त्वाचं काय तर डॉक्युमेंटेशन करायचं. एवढा विचार करून थांबायचं नाही. तर असं एक टेबल बनवायचं की याच्यामध्ये रिस्क काय काय आहेत. आपण 1 2 3 एक सॅम्पल म्हणून वाचून दाखवलं की सॅम्पल फ्लडिंग डिस्टर्ब सप्लाय चेन डिस्ट्रप्शन, इम्पॅक्ट काय, डिले इन डिलिव्हरी, लाईकलीहूड. आता आपण मुंबईमध्ये आहोत, सो लाईकलीहूड इज लो, सिव्हिअरिटी इज लो, आणि मग ॲक्शन प्लॅन काय, असं एक संपूर्ण एक टेबल बनवायचं. सगळ्या रिस्क आयडेंटिफाय करून त्याच्यावर आपण काय काय ॲक्शन घेऊ शकतो, तसंच अपॉर्च्युनिटीज आयडेंटिफाय करून त्याचा आपल्याला काय काय फायदा होऊ शकतो हे संपूर्ण टॅब्युलर फॉर्ममध्ये करायचं. आणि 9.1 म्हणते की हे नुसतं करून थांबायचं नाही, या प्रत्येकाचं मॉनिटरिंग करायचं. तर प्रत्येक वेळेला याच्यामधून आपण काय काय स्वतः करू शकलो त्यासाठी सेट क्लिअर मेजरेबल की परफॉर्मन्स इंडिकेटर्स KPIs, यूज रिलायबल डाटा कलेक्शन अँड ॲनालिसिस मेथड. हे जरा थोडं कठीण आहे. आपण आपल्या लोकांवरतीच विश्वास ठेवून ही माहिती गोळा करायला लागते. आणि रेग्युलरली रिव्ह्यू रिझल्ट अगेन्स्ट ऑब्जेक्टिव्ह अँड टार्गेट दिस वी डू मंथली. This slide, these 2 slides I will escape and go to the last 2 slides. आम्ही स्वतः काम करताना काय काय केलं. तर आपण जे कॉन्क्रीटचे क्यूब टेस्ट करून वाया जातात ते सगळे क्यूब आम्ही ऑफिसमध्ये, नवीन ऑफिसमध्ये एक डेकोरेटिव्ह एलिमेंट म्हणून वापरलं आणि दॅट हॅज गिवन अ नाईस लुक. सेकंडली आपण सगळेजण ट्रेसिंग रोल वापरतो. त्या ट्रेसिंग रोल ज्याला बांधलेले असतात ते पुठ्ठ्याची नळी जी असते त्याच्यापासून आम्ही फॉल्सलिंग केलं आणि दॅट इज मेड ॲज अ नाईसली लुकिंग गुड एलिमेंट. तिसरा, सगळेच जण AC वापरतातच. त्या ACचं जे कंडेन्सेट वापर आहे, पाणी जे येतं ते सगळं पाईपलाईनमध्ये एकत्र करून आम्ही आमच्या वॉश बेसिनला वापरतो. आणि सगळ्यात महत्त्वाचं म्हणजे नॅचरल लाईटिंग इन केबिन. तर सगळीकडेच फॉल सिलिंग करून आर्टिफिशियल लाईट लावायची पद्धत. पण असं असताना जेवढ्यांच्या केबिन या आउटसाईड फेसिंग आहेत ते सगळेजणं कुठल्याही प्रकारचा लाईट न लावता ते आपल्या केबिनमध्ये बसतात. हे टिपिकल 2 टेबल्स आहेत त्याच्यामध्ये आम्ही ऑप्टिमल डिझाईन म्हणजे स्टील कन्झम्पशन किती झालं हे प्रत्येक प्रोजेक्ट संपल्यानंतर मेजर करतो. तुम्ही बघितलं तर चौथा जो आयटम आहे की टार्गेट काय आहे तर 4.5 kg 5 kg तिसरा, आणि प्रत्यक्षात काय झालं तर 4.5. असं प्रत्येक प्रोजेक्टनंतर घेऊन मंथली मीटिंगमध्ये ज्यांचे प्रोजेक्ट पूर्ण झाले त्यांनी हे डिक्लेरेशन द्यायचं. आता हिअर वी हॅव टू बिलीव्ह अँड त्यांचे जे काय एफर्ट आहे त्यावरती रिलायबल सोर्स आहे की वेगळा मुद्दा राहतो असं एक आहे. आणि तसं दुसरं सिम्पल आहे की प्रमोशन ऑफ इको फ्रेंडली मटेरियल्स. तर आम्ही प्रत्येक ड्रॉईंगवरती नोट्स टाकतो की आपण GGBS यूज करूया, फ्लाय ॲश यूज करा. असं हे सोपं आहे. ते सगळ्या ड्रॉईंगवरती त्याचा रिझल्ट 100% आहे. सो विथ दिस आपण कन्क्लुजनला येऊया की इंटिग्रेट क्लायमेट consideration in your management system, adopt eco-friendly practices, 3 invest in innovation, 4th is measure and minor impact, and final collaborate and share knowledge. तर एक्झॅक्टली हा जो मुद्दा आहे की शेवटी त्याच्यामध्ये त्यांनी असंही सांगितलं की हे याचं सगळ्या लोकांपर्यंत पसरवायचं या दृष्टिकोनातनं आजचा वर्कशॉप हा त्यातलाच एक स्टेप म्हणून आम्ही घेतो. दिस फॉर आवर इंजिनिअरिंग अँड आर्किटेक्चर फॅटर्नरी. थँक्यू. दोघा तिघांना थँक्स म्हणायचं राहिले. पांडे PP पांडे जे आमचे GM प्रोजेक्ट्स आहेत ही सगळ्या आयडियाज त्यांनी इनिशिएट केल्या. आणि श्रेयांशू की जो आता सगळं IT हँडल करतो आहे त्याने सगळं प्रेझेंटेशन बनवायला मदत केली. आणि बराक ओबामांचं असं वाक्य होतं की वी आर द फर्स्ट जनरेशन टू फील द फुल इफेक्ट ऑफ क्लायमेट चेंज अँड द लास्ट जनरेशन दॅट कॅन डू समथिंग अबाउट इट. त्यामुळे आपणाला ही शेवटची संधी आहे, नाहीतर हे खूपच हाताबाहेर जाईल. थँक्यू.
Thank you, sir. We appreciate Engineer Jayant Kulkarni, MD, Epicons Consultants Private Limited, for sharing your expertise and enriching us with such meaningful perspectives on the role of structural design engineers on approach of ISO 9001:2015. It is my honor to introduce Engineer Rohit Koregaonkar, Partner Chromatics MEP Consultants, to deliver a lecture on the topic From Building to Communities, Climate Change Mitigation through MEP Services. Engineer Rohit Koregaonkar's professional experience includes MEP designing expert with experience in residential, commercial, industrial, hotels, hospitals, and educational institute. Partner at Chromatics, a MEP consulting engineers, senior engineer at TDA Consulting Engineers Limited, senior project and design engineer at Hydromechanical Consultants, service design engineer at Ramat Group of Hotels. His affiliations and awards include Honorary Director of Water Management Plumbing Skill Council, Member of Indian Plumbing Association, Fire and Security Association of India, Associated Member in Institution of Values. He was a President of Rotaract Club of Thane Central. During his tenure, the club was ranked in the top 10 in Mumbai. Let us warmly welcome Engineer Rohit Korgaonkar as our session speaker. Please, sir.
Thank you for getting me on board as a presenter for climate change mitigations. So basically, as everybody knows की सकाळपासून climate change mitigation पर discussion चालू है. My part is mainly respect to MEP part, so I'll be speaking about that today. So introduction with current scenarios of climate change. Everybody knows what climate change is right now. The main driver of climate change, what everybody knows today, is mostly temperature that is increasing and the beginning of the story of climate change. But it's not that only. There are a lot of other major problems that are causing climate change. So how does climate change and MEP go together or affect each other? Contribution of carbon emissions is almost 57% of total emission that is happening nowadays. Architecture, engineers and construction AC industry should therefore be at the forefront of movement to address climate change effectively. MEP systems negatively affect climate change through high energy consumptions, use of powerful greenhouse gases refrigerants and embodied carbon associates with manufacturing and transportation. HVAC systems are largely energy consumers, because of which high energy gets used in the entire building premises. The repeated cycle of manufacturing and installing new equipments means a constant stream of embodied carbon emissions over the building's lifespan. Causes of climate change with respect to MEP: energy consumption, greenhouse effect, heat island effect, demand of manufacturing and resources, indirect emission and destruction of marine ecosystem. Effects of climate change on MEP system: physical damage from extreme weathers, what we are seeing right now in lot of north belt areas. Higher energy consumptions because the ambient temperature is increasing and we have to design the HVAC system wherein first we used to design for 24 degrees, but now we are getting from lot of clients suggestions, please design it for 22 or 21 degrees Celsius. Even 2 degree change in design is a huge impact on the kind of load requirement that the HVAC system consumes. Water scarcity, power outages, increased demand on HVAC systems and increased efficiency and lifespan. Mitigation goals and net zero requirement for MEP sector focuses on eliminating of significant reducing the carbon footprint of building systems through energy efficient design. American Institute of Architects with Architecture 2030 has committed a framework wherein by 2030 they will become carbon neutral. By 2015 it was 70, by 2020 it was 80, by 2025 they have almost achieved 90% and hopefully they will achieve it by 2030. Mitigation goals and net zero requirements for MEP 2040, a challenge which the AEC sector is asking us to do: transform mechanical, electrical and plumbing systems in such a way that it affects the net zero carbon by 2040. The AC 2050 commitment is an initiative for structural engineering firms to eliminate embodied carbon and their projects by 2050, the topic which is already covered by my previous speaker. self-sustainable practices for MEP. Water efficiency, energy and atmosphere, material and resourcing, indoor environment quality, innovation in operations and regional priority, sustainable sites. So basically, what it means more or less is that try and use renewable energy, renewable materials, and see to that the material is being used from within a radius which is close to the site itself, so as to reduce the transportation requirements. This is a small video which the Gift City has installed 2 years back, wherein everything is met by them with respect to MEP.
The GIFT, Gujarat International Finance Tech City, is planned with state-of-the-art infrastructure, which makes GIFT a smart city. Some of its highlights are power. At GIFT, the power reliability is 99.999%, implying an annual outage of 5.3 minutes. It will have a feed of 750 megawatt from two 400 kV lines. Receiving substation will be gas-insulated switchgear substation. 20% of total load is assumed as emergency requirement and shall be generated through in-house gas-based power plant. Power distribution will be via utility trenches through HD cables at 33 kV. Compact substations, depending on the load density, shall be placed at the refuge floors of tall buildings to enable connectivity to all floors and minimize distribution losses. District cooling system. GIFT will be India's first ever model of city-wide district cooling system, a highly energy efficient system that will air condition the city. The cooling demand will be met through GIFT's decentralized, modular and interconnected DCS plants to meet the SEZ and non-SEZ requirements efficiently. Chilled water will be produced at 4.5 degrees Celsius at the DCS plant and distributed via pre-insulated pipes through trenches to energy transfer stations located at the basements of each building. The BTU metering will be provided at the primary site of the energy transfer station at the individual building location to measure the chilled water consumption by each building. The returned water will be carried back to the DCS plant to reject the heat by using the cooling towers. Additionally, a thermal storage will be charged at night hours between 10 p.m. to 6 a.m. to utilize the night better demand management. DCS by design will overall improve efficiency, conserve energy, save space, and reduce environmental impact. Integrated water management system. GIFT's entire water requirement will be met from the Narmada Canal via the dedicated raw water pumping station at Nahoi, which is 11 kilometers away, with Samruddhi Sarovar being the receiving point as well as doubling up as master reservoir, storing up to 15 days water requirement of the whole city. From Samruddhi Sarovar, the water will be pumped to water treatment plants, positioned and designed for efficient and equitable distribution of water system in grid or loop pattern. In line with sustainable infrastructure vision, GIFT is planned for zero discharge. 100% wastewater and HVAC blowdown water will be tertiary treated to the desired quality and recycled to use for DCS, flushing and horticulture purposes. Automated waste collection and segregation. Automated waste collection and segregation system will source all the waste generated from various establishments and green areas at GIFT. It will be conveyed through the chute by gravity and stored in temporary storage section. The solid waste from temporary storage section will be conveyed to the central waste handling facility through automated waste collection system. The recyclable waste will go to the recycling vendor and compacted non-recyclable waste will go to the landfill or waste to energy plant. Advanced infrastructure system and management. A dedicated utility service corridor housed in huge underground trenches works as the lifeline for GIFT. It facilitates, monitors and manages the utility network of the entire city. A utility trench is laid alongside the road measuring about 7.6 meters by 6.2 meters, which is divided into wet and dry sections to carry all the trunk utilities till the block perimeter. For hassle-free operations, a designated maintenance vehicle corridor with overhead gantry crane is provided. All the piping and instrumentation is sensor-based and coordinated with the centralized city command and control center. In case of any fault, the information shall be relayed at C4 in real time and will be attended immediately. Intelligent building management system and intelligent infrastructure management system. GIFT adheres to the most advanced building and infrastructure management systems. IBMS and IIMS is implemented as an integrated open solution which enables all-time connectivity with the centralized city command and control center. Developers and enterprises can make use of the flexibility of IP technologies to realize interoperability and conversions. Intelligent building management system will enable energy management by HVAC and lighting control, water monitoring, facility management, safety and security for its occupants by fire detection and alarm system, evacuation and public address system, security and surveillance, access control system, and parking management. ICT infrastructure. At GIFT, the Information and Communication Technology ICT is built to deliver competitive advantage to organizations operating regionally and globally with its pre-enabled on-demand infrastructure. The ICT infrastructure includes 24/7 high-speed connectivity across the campus, on-the-move connectivity across the city by pervasive Wi-Fi network, and highly secured Tier 3-4 data centers offering highest uptime available. The ready-to-use platforms such as cloud computing, financial extranets, dedicated access to closed user groups, city e-portal, IPTV, internet gateways using fiber to the premises technology are all built on green ethos.
Yeah, so this was all about Gift City, and most of it is, if you can go and visit, it's actually been done there. And it talks about the future ready infrastructure, which we as India already has it and already installed in one of the projects. Existing government policies and practices that we need widespread applications. Indian policies, practices, and implementation is the key. Tri-generation or combined cooling, heating and power is a simulation of electricity, heat and cooling all from a single source. Wherever this demand for both all type of energy is given, technology seems to be a promising approach to increase energy efficiency and reduce energy cost. This was first installed in New Delhi's Jai Prakash Narayan Apex Trauma Center in 2010. Some of the potential consumers of the technology are technology park industries such as dairy, food, beverage and pharmaceutical industries. Another pilot project for solar energy harvesting projects was done by Omkareshwar in Madhya Pradesh, wherein the floating solar power plant was installed. It saves water from evaporation, avoids land acquisition requirements, thus aiding energy generations as well as water conservation. Projects involving huge water bodies like lakes, ponds can be encouraged to use this model for renewable energy harvesting in return of some incentives by the government. Again, in Varanasi, Indian Rail's locomotive has commissioned a 70-meter removable solar panel system consisting of 28 panels generating 15 kilowatt of power situated between existing railway tracks. This innovative project utilizes previously unused space, reducing the need for land acquisition and generates clean energy for the loco shed itself. Another example is the solar tree, which is installed in Durgapur. Each solar tree has the potential to save 10 to 12 tons of CO2 emissions being released into the atmosphere as greenhouse gases when compared with fossil fuels. The Indian government can promote these niche projects in building and residential complexes by expanding the PM Surya Ghar Mufti Bijli Yojana to include them, offering specific subsidies and financial incentives for their installation, mandating them in new constructions, and launching awareness campaigns to highlight their aesthetics and energy benefits. Thirdly is ultra low flow and adaptive fixtures. So most of them know, or most of you know about low flow fixtures that are being used nowadays, but there is something called as ultra flow low fixtures which requires 0.5 to 1.5 GPM, and the kind of technology that is growing nowadays, it uses or it saves 70% of the water and provides the same effect that a normal fixture would provide. Fourthly is geothermal heat pumps, or the energy which is stored inside the earth is being used for heating and cooling of the air conditioning equipment. So basically, wherein the loops are situated or installed inside the surface of the ground, the fluid circulates through the loop and carries the heat to the building. Chilled water is distributed to different rooms in MS pipes. Fan coil units are provided in different rooms which cools these rooms. The effect is significant. Lower energy bills due to high efficiency, improved comfort through consistent temperature, environmental sustainability, quiet operations as no outdoor unit, longer lifespan for the system components, free hot water, further boosting energy and cost saving for homeowners. Foreign policies practices, adaptation is strategy. So some of the examples in foreign which are already being used are, in Japan there is a city called as Suta Sustainable Smart Township, which was developed by Panasonic on a former factory site. It was opened in April 22. Its primary goals are to promote multi-generation living, achieving carbon neutrality and address social challenges like Japan's aging population. The town's energy system prioritizes renewable energy and resilience against natural disaster, a common challenge in Japan. The town aims to generate virtually 100% of its electricity from renewable sources. Photovoltaic systems are installed throughout the town. Large solar batteries provide backup power to ensure resilience during outages. The entire wellness complex is advanced with E&E farms, fuel cells that generate electricity and heat from city gases. Indian adaptation. Creation and construction, growth, maturation and evolution. This combination enables the community to operate on its own microgrid during power cuts, a common challenge in many Indian cities, which we can look at. Another example is the Metropolitan Area Outer Underground Discharge Channel, GCANS, which is a massive flood diversion system created in Tokyo that combates increasing frequency and intensity of flooding caused by climate change and urban expansion. It acts as an underground reservoir and conduits, channelizing excess rainfall from rivers and storm drains during heavy intensity rains. It gets stored temporarily and then gets pumped into the Edo River. This system prevents billions in damages, protecting the densely populated Tokyo metropolitan area by mitigating several rainfall events that are exacerbated by climate change. Indian adaptation. So instead of a single mega project like GCANS, India's cities can focus on creating smaller decentralized underground storage systems connected to the primary urban drainage network. This also could be integrated with large infrastructure projects like metro stations, commercial complexes, and residential townships. MEP design can incorporate rainwater harvesting and local storage solutions like revival of boulis or step wells, which we already have in lot of areas in India itself. This green-blue infrastructure approach aligns with modern sustainable urban planning. New policy suggestions. Indoor air quality. Current issues: no uniform law, smaller projects struggle with compliance cost, fragmented guidelines. Need unified and scalable IAQ legislations. Proposed framework can be done as giving tax benefits, health-based pollutant limits, ventilation benchmarks, CO2 less than 1000 ppm are the guidelines that can be provided. Tiered compliances on the basis of size of project is what we can do. Baseline simplified IAQ steps like minimum ventilation and basic pollution checks, intermediate building periodic monitoring of IAQ parameters, and advanced continuous IAQ monitoring system. Current issues are limited financial push, existing schemes focus mainly on industrial efficiency, need extended performance linked incentive to building sector. Proposed framework, subsidies, tax benefits, adopt PAT model, monitoring mechanisms, scalable approach. Outcome: drive energy efficiency retrofits, align building sectors with national energy efficiency targets. District cooling, as we saw in Gift City, can be used. The outcome is about 30 to 40% energy saving. Dual plumbing mandates, which again is being used in this city and quite a few other cities as well. NBC itself states using of single or dual plumbing, but single stack system itself uses lower cost and space availability. So another need is shifting towards dual plumbing system, that is having domestic and flushing lines separately for all kinds of buildings. This will cause grey water segregation, gradual transition, incentives, subsidies for them, updated NBC provisions to reflect water scarcity. Outcome: enables large-scale grey water recycling, sustainable water management goals. City-level purple pipeline microgrid is system which we can look at. So basically, wherein the recycled water network is created in the entire city, which even we can do, and wherein the STP water in most of the projects gets overflowed into the stormwater drainage or the sewerage line, because only 30-40% of the water is being used in the building itself, can be connected to this purple pipeline, and this line in turn can give water to irrigation requirements, landscaping requirements, farmers, and during drought seasons as well. Cluster based shared fire protection system. So nowadays, as everybody knows, as per NBC 2016 part 4 also, every building mandates fire. It requires a storage system for each building. So rather than going for a storage system for each building, we can go for a common cluster development wherein 10 to 15 close by localities can be given a common fire water tank, wherein a centralized pump houses runs fewer but larger pumps at higher efficiency point, cutting down energy use. Kinetic payment technology is a technology wherein the energy from the footsteps into the electricity using sensors and generators beneath the surface itself. People walk, the pressure activates mechanism that produce power, which can be stored or used for local needs such as lighting, phone charging or data centers. Examples include London Bird Street, where kinetic tiles power street light, and DuPont Circle in Washington DC, where foot traffic is harnessed for street lighting. Swimming pools, especially ozonated, can be used as a storage reservoir for providing firefighter requirements, so that RCC tanks can be stopped using. Emerging tech solutions for mitigation through MEP. People flow analysis, BIM and digital twins, Internet of Things, modular and fabricated construction. People flow analysis helps in mitigating climate change by creating high energy efficient buildings that use less power for heating, cooling and lighting. IoT now connects HVAC lighting and security system. This system can provide facilities that automatically adjust comfort setting and energy use. A smart building can dim lights and dial down AC in empty rooms, improving efficiency and occupant comfort while enhancing security. These connection systems even enable predictive maintenance by flagging issues before they escalate, cutting downtime. Emerging tech solutions, BIM and digital twin, wherein a digital twin of the existing building can be created or the proposed building. You can think of it as a sim city, wherein using BIM and digital twin, engineers can clashes or inefficiency in design before construction. Facilitate managers can monitor systems in real time to tune performances. This means fewer surprises during construction and more proactive upkeep over a building's life. Physical assets and digital twin. Modular and prefabricated construction. To save time and waste, MEP components are increasingly built off-sites in modular system and then bought onto the site and retrofitted. So prefabricated MEP systems have been shown to cut construction time significantly while minimizing material wastage as well. This means faster occupancy and fewer cost overruns due to weather or on-site errors. Challenges in implementation policy and practices are high initial cost, complex integration, maintenance and expertise, eco-diversity, resistance to change, and technology limitations. So with this, I conclude my presentation. Knowing is not enough, we must apply. Willing is not enough, we must do. Thank you.
We are grateful to Engineer Rohit for enriching us with future-ready infrastructure. I would like to invite Engineer Yadav Kamre, Executive Committee Member, ICI Mumbai, to felicitate Engineer Rohit Kargaonkar. Thank you, sir. With great respect, I would like to invite Engineer Vikas Ramgude, Joint Managing Director at Maharashtra State Infrastructure Development Corporation, MSIDC, to deliver expert remarks. Engineer Vikas Ramgude obtained degree in Civil Engineering from Government College of Engineering, Pune in 1989 and Master in Engineering from Government College of Engineering from the same college in 1994. Working with PWD, Government of Maharashtra since 1995, he has more than 35 years of experience. Let us warmly welcome Engineer Vikas Ramgude to deliver expert remarks.
गुड इव्हिनिंग. ऑलरेडी ऑडिटोरियम खाली झालेलं आहे आणि ते मला जास्त खाली करायची इच्छा नाही, त्यामुळं आय विल बी इन ब्रीफ. काही सिमिलॅरिटीज म्हणजे इट इज अ व्हेरी एक्सलंट इनिशिएटिव्ह टेकन बाय ऑनरेबल जयंत कुलकर्णी सर. 4 कुलकर्णींनी आपल्या 4 सेशनमध्ये इथं अधिराज्य गाजवलं आहे आणि चौघांच्या नावामध्ये जयंत, अभिजित, काय विजय, असं सगळा विजय तिथं सामावलेला दिसला मला त्या ठिकाणी. आणि इकडं महिलांच्या बाजूने स्वाती मॅडम आणि योगिनी मॅडमने पण त्यांची बाजू जोरदार केलेली आहे. आणि रोहित पक्षाचं सेपरेट वैशिष्ट्य असतं, विशेष हे असतं. तसंच रोहित कोरगावकरांनी आपलं शेवटचं सेशन म्हणजे अक्षरशः ते काही मुद्दे टिपून घ्यावेत आणि ते इम्प्लिमेंट करावेत अशा पद्धतीचं त्यांचं छान प्रेझेंटेशन होतं. I will not take much of time, but we should not only listen, but we should do like that what the Jayant Kulkarni sir has implemented in office. So mitigation with this climate change, we have to start from ourselves, and for every action, that is from starting from the water bottles to all. So from small activities we should start. And regarding design, it was a very eye opener to me. Said we are always conservative. What the Jayant Kulkarni sir said, what is the consumption per square feet for a different, of course it is not a unique figure, but for different types of buildings and different configuration there is a common range, but we are generally on the upper limit. So as a designer we have upper bound and lower bound, but we are always try to touch to the conservative side. And depending, and the second thing from I think from the presentation of Mr. Suhad Jadhav, that is the configuration is much more important than playing with the numbers of the say strain level, stress level, bending moment and shear force. So appropriate selection of the form without sacrificing the things is what I learn is very important. We are going for some nearly 7,000 kilometer PQC, and we have specified the minimum thickness of PQC. So designers are fitting it from 220 to 300, and our specified thicknesses are of the order of 250 mm to 270 mm. Again, if minimum is specified, what the people are doing? They are trying to manipulate to so that the result is below than minimum one, and now they are providing the minimum one. And so these are the things what is happening. So we have to first that in Japan, the first 10 years they imbibe the social ethics and commitment to the society in the students for their the initial 10 years. So that is also one thing which is required. And secondly, that designer basically the major carbon footprint is blamed to be with the construction, so that is with the civil engineer, and we are only the civilized engineers. Rest are the mechanical, electrical, electronics and whatnot. So our the sole responsibility is to look into this. And also I will just add one thing, that to regulate the irrigation department or the water resource department has given blue line and red lines at the no development zone. The red line is for 100 years return period, and this is for 50 years return period. But it is many times because the builders only understand the square feet carpet super built up and whatnot, and so and they want the land cannot be created. It is created by some our say going in deep or going say up we can, but because of that the constructions are done in the say blue line zone, and many rivers have siltations, dams have silted up, and I have read a very beautiful beautiful thing by some Dr. Pawar, that नदी आपला मार्ग कधी विसरत नाही. आत्ता जे सोलापूरमध्ये जे मेजरली सिन्हा नदीच्या ह्याच्यामध्ये जे झालं आहे त्याच्यामध्ये इट इज एनक्रोचमेंट ओव्हर दॅट. देर वॉज अ फेमस जाहिरात की कितना भी खाओ और हजमोला से बचाओ. So one of my friend who was dean of JJ hospital, he said की आपली परंपरा आहे की 80-90% लेवललाच थांबायचे भुकेच्या. हां, तर हा कोण जाहिरात करणार आहे त्याला पहिले फटके मारले पाहिजेत म्हणे की पचत नसेल तर खातोच कशाला. तर या ठिकाणी सांगायचा उद्देश हा आहे की बेसिकली आपण आपल्या रिसोर्सेस केअरफुली वापरल्या पाहिजेत आणि 95% डिपेंडेबिलिटी हा आपला नॉर्मल हा आहे. तर आपल्या सेफ्टीमध्ये पण वन ऑफ द डिझायनर हॅज एक्सप्लेन व्हेरी नाईसली की यू आर इन्क्रीजिंग द लोड, यू आर कॉन्झर्वेटिव्ह ऑन डिफरंट कॉम्बिनेशन्स, अगेन यू आर कीपिंग इंटरॅक्शन रेशो 0.8. Everything is concerned, let us have say respect for one interaction ratio. Again, keeping the PO upon security down. So these things shall not be done, and we should be alert, and we should use the things very optimally, and we should put the pressure on even government side. Though I am representing government side, whether the URI road is required to be concreted. Because bituminous road, the sole purpose of using bitumen is the waste product. Okay, but now everything is shifted to concrete, and the policymakers, because there are different ideas and their advices are limited in say numbers, they advise that there should be even social say pressure on that what is required and what is not required. So need finally the nature is giving everything we needed, but it will not satisfy our greed, and the major issue of climate change is coming through that. And what the Jayant Kulkarni sir's the last template has shown, the Barack Obama's statement, it is very true that we should be alert. And in philosophy the last word is that when you have arrived on this earth, how was this earth, that you should improve it when you are living by say at least 1 or 2%, 5%. And with that I will stop. I will stop here, and I will be thankful because even the small quantum is remaining, but as a great listeners are remaining, and they have not clapped, that they have allowed me to speak. So I request you now to clap because I am stopping. Thank you very much.
Thank you, sir, for your expert remarks. I would like to invite Professor Abhay Bambole, Chairman ICI Mumbai, to felicitate Engineer Vikas Ramgude. Thank you, sir. I would like to invite Dr. Abhay Bambole to give vote of thanks for the today's event.
नमस्कार मंडळी. मी कधी कधी की नाही आपलं सकाळी 10 वाजता लेक्चर सुरू करतो आणि संध्याकाळी 6 वाजेपर्यंत घेतो, आणि तरी पण मुलं बसलेले असतात. तशाच प्रकारचे सिन्सिअर लोक दिसतात इकडे. आजचा हा कार्यक्रम ऑर्गनाईज करण्यामध्ये आणि तुम्ही लोक आणि गेस्ट लोक येण्यामध्ये आणि सगळ्या हॉलचा AC वापरण्यामध्ये आपण जवळपास 100 किलो कार्बन डायऑक्साईडचं उत्सर्जन केलेलं आहे. तर आपली पहिली प्राथमिक जबाबदारी आहे की आपण त्याचं निराकरण करावं, आणि निराकरण करणं शक्य आहे. Those who are structural engineer, they can design the building, do the value engineering, and very simple thing. Nowadays most of the buildings are with the shear wall. Please refine the element size and you will get more economical solution. When the columns are large size, you have not been restrained or constrained and nobody is putting gun on your head that you take the only line element. You can take the wall element like shell element also, at least in one longer direction, and try to model it as a shell rather than simply call. It will attract, it will give very good result, which is already there. and that's why you can save, at least a few kgs or few tons of the steel. And then one steel, when you manufacture 1 ton of the steel, we normally, the carbon emission is almost same, 1 metric ton. For 1 metric ton of the steel production, 1 metric ton of the carbon emission. Similarly, those who are, again, we can optimize the concrete sizes, the sections. Unnecessarily, we are putting so much that is not required many a times. And those who are in field working, project management on the sites, please try to save the waste of the concrete. It is significant waste. Many a times, we don't calculate, estimate, plan, and there is around 0.5 meter cube of the concrete is there in the mixer, and that we just throw or put it somewhere. 1 टन सिमेंट मॅन्युफॅक्चर करायला जवळपास 0.6-0.7 टन कार्बन उत्सर्जन होतं. ते तिथे पण आपण वाचवू शकतो भरपूर. बरोबर आहे की नाही? तर आपण आज वाया घालवलेलं म्हणजे उत्सर्जित केलेलं कार्बन तरी आपण पुढच्या आठवड्याभरामध्ये भरून काढूया. आर यू गाईज विथ मी? ॲटलीस्ट दोज आर देअर? ओके. So let me do my job. At the outset, I must, thank our Honorable Director, Dr. Sachin Kore. Those who are there in the morning inaugural session, you have heard him. That, we always, get surprised. He always talks very relevant and very to the point. Okay. He said that, in the evening, if you can give me something material, it's okay, but otherwise I can talk. And he talked very relevant. Thank you. I must thank our Honorable Director, Professor Sachin Kore. Very young, enthusiastic director. We have been blessed with, a good director, and then we are progressing in the leaps and bounds. Then our Deputy Director, Professor Avade, for gracing the occasion. Then, Honorable Jayant Kulkarni Sahab and Mr. Deshpande for gracing the occasion. And then my friend whose birthday was yesterday, Dr. Thomre, and he's also elected as President ACI. Very young chap, very enthusiastic and energetic, and lot of good work is being done by him in PW, in BMC and all the professional bodies also. I don't know how he manages. I also thank our ICI members, our ICI committee, Jitendra Pathak and then Himdra Shirbhato for being in the present and being successful in organizing this particular event. I thank Madam Swati Choksi for very elaborate talk on life cycle assessment, and then those who listen to first time A1, A2 and B1 to B8 काहीतरी नवीन शिकायला मिळालेलं. Thank you, madam. And then I think we should be learning this also, and then try to do the complete life cycle assessment. And then we learn this embodied carbon and other things. Thank you, Kulkarni Sahib. He's a veteran, and then last 40 years, since I was student, from the second year onwards, I have been listening to him via Kulkarni Sahib. And thanks for getting Kulkarni Sahib, getting Jayant Kulkarni Sahib for getting him on the board. And let us listen, and then we should be listening. Ramugade Sahib has told me, Professor Bambole, can you introduce non-credit course on sustainable development, sustainable engineering? Yes, we are trying to do it, and then we'll be needing the help of, Jayant Kulkarni, VR Kulkarni, Swati Choksi madam, to maybe a course of 10 lectures, 10 hours, or maybe Saturday, Sunday we can have. And those who are interested, we can give, and that will definitely help them, in their placements, and it will help them to sustain the, do some work in sustainability. We had, my friend Abhijit Kulkarni, very nicely, very, fine engineer from Bureau of Fault. Very detailed lecture he has given. Then the presentation by JSW Cement. Before that, Mr. Ajit Kulkarni has given his lecture. And then we have listened first time our own colleague, Professor Ninadok. So we are also have good speakers in the field of the, environmental and sustainable development. Or Madam Yogini Deshpande, unko to kya कहने, every time she talks very nicely, and then very detailed, very fine consultant and engineer, and then all the fairer sex, she is the torch bearer. Okay, Madam Choksi, and then as Ramugade Saab said, we want more women, on this particular field. And whenever I go for any particular site visit, I see a site engineer is a lady engineer, I feel very happy about it because their presence should be there. Then we had Suhas Jadhav, and very nice and detailed presentation given by him, and then our own Jain Kulkarni Saab on ISO. Lastly, engineer Rohit Koregaonkar, the Gift City. So when we are constructing a gift city in Mumbai and around, we want a similar city. You gifted a city to the Gujarat, not to the Mumbai and Maharashtra. So we are looking forward a gift city in and around Mumbai. And my old friend and then our well-wisher and guide, a veteran in encyclopedia of the bridge engineering, Mr. Ramugadeji. Whenever he has got millions of photos of bridges, and you say that there is some situation, he will dig out some photographs and he will start explaining him. They have developed an encyclopedia, a coffee table book on the bridge designs, some templates. Do you guys have that copy? Ramugade Saab and Sheikh and other people, they have published that book on behalf of the PWD. Then all the other our volunteers and my colleague Kavita Fasate, then Rashmi and Jacinta, those who manage the show, and then all the young guys over here, because I'm aging, so sab mujhe young hi lagte hai. You may be 30, 40s, but for you guys, for me, you are young. Okay. And you guys sitting over there, अगर आप लोग नहीं रहते तो फंक्शन कैसा होता था, So ये आखिरी के जो बच्चे हुए जो 50 लोग हैं ना, वो 5000 के बराबर है. So my salute to you. I bow in front of you, okay, and I say that we with the people like you only, this type of seminars and then the conferences, workshops, they see their success, and with the note that let us do our bit for the saving this Vasudhara. आपल्या सगळ्यांचं कर्तव्य आहे ह्या वसुधरेसाठी भूमातेसाठी तिची काळजी घेणं. छोटं काहीतरी करावं. आपलं तेलुगू किंवा तामिळमध्ये कुंचम म्हणतात. लेट अस डू अवर स्मॉल बिट एक डेली लाईफ. Yesterday I visited Abhijit Bangar's additional municipal commissioner's office. The bottles were, they were not the plastic PET bottles. The water bottles were the glass bottles, and the tumbler was kept. So let us do that from our office also. Let us, otherwise how much, plastic waste we are generating. So let us do a small thing and take this message that we are the torch bearer and we are here to save the earth and give a nice, particular, good future to our kids and the next generation. Thank you. That's all.